Hello. So it's a paper co-authored with Richard Baskerville and Recker. And so what I'm going to talk about, I have 20 minutes and 20 slides. Green systems is a hopelessly overused term as of today. We have analyzed the literature on green systems, green IT, sustainable IT, things like that. And we have found 3 causes for the overuse. And based on that, we have derived some principles, 8 principles for how to develop green information systems. So that's what I'm going to talk about. So some of the problems we have today is that people are sub-optimizing, so they may be green for one of the goals that Amin and just presented, but they are then hurting the others. So they're sub-optimizing, or they define green too narrowly, or they don't precisely determine what environment they're talking about, or they overlook important things. So that's kind of the problem analysis, and you can read more on the paper if you like. I would like to concentrate on the principles. So the principles is an example of a design theory. It's a way of representing a middle-level design theory. So we also take the starting point in the case, the Dieselgate, and that's an instance problem, and Volkswagen is still struggling with coming up with an instance solution. So, but the principles exist at the abstract level, so it's valid for a class of problems, not just for a single instance. So that's what makes it a design theory. So to make it short, the 8 principles that we have identified, you see here. So they fall in 3 groups: problem formulation principles, design principles, and evaluation and learning principles. And I'll go over the principles one by one. So the first principle is that you have to place your problem both within the inner and the outer environment. So it's not enough to just look at the close-by environment. You have to look at the environment as a whole. So for example, if you buy a Tesla, a new car, that runs on electricity, it may be sub-optimizing. You may think, oh, that's green, I have a green car. But if that electricity is produced by a coal-fired power plant, it's not green at all. So you have to take into account the outer environment of where that electricity is produced. And it's not, we're not saying you cannot make it green. If your car only charged when the power was coming from solar or wind power or something like that, it would be much more sustainable, much more green, and that would take into account both the inner and the outer environment. The second principle is that you need to identify the stakeholders within the ecology that you're talking about. So, and what's really interesting here is that when we talk about green, we are not just talking about today's stakeholders, that's classic project management. We're talking about future stakeholders. So you have to identify the future stakeholders, the people here on Earth that will be here in the future and will be influenced by the design you're making today. And that's kind of a hard thing to do, because estimating the future is hard enough. But estimating what future stakeholders will think and what will make them happy, as you do in a stakeholder analysis, that's even harder. But if you're not trying, the likeliness that you will actually make a design that is green and will fit and suit the future stakeholders is close to 0. Then the third principle is that you should delineate what system are you talking about and the uses of that system. So that's not really new, so let me go to the next bubble, the design bubble. Here comes something interesting, namely, you have to find the sustainability fit function. So what design will fit and derive and sustainability? And this sustainability function will have to take into account the things you identify as 3 principles with the environment and the stakeholders and the users to come up with this sustainability fit function. And since we wrote this paper, we have actually worked on this and worked more on this. So we now talk about that you have 3 sustainability fit functions. The first one is conservation, meaning that you are establishing eco-efficient operations to an IS that helps preserve the current state of an ecosystem. So that's one kind of sustainability. The second fit function is restoration. So you help an ecosystem to return to a previous state or equilibrium. And the third sustainability fit function is resilience. So you're empowering a natural ecosystem to withstand and recover from any disturbances. So you have to find the sustainability fit function in your design. And you can take inspiration for one of the 3 here or all of them. So that if we add that to the little figure from before, we have today's stakeholders here and future stakeholders here, and you have the design here. Conservation is going on here, restoration is here, and resilience is really the very interesting fit function, sustainability fit function, because that will be about the future stakeholders. So that's probably the most interesting fit function. So what you do here is you derive the sustainability fit function, and it's of course dependent on your objective, and it can be either conservation, restoration, or resilience, or more of them. Okay, principle number 5. You should ensure that the artifact that you're designing provides affordances for the sustainability of both the inner and outer environment. So it's not enough to identify the environment, you also have to think about how can I afford that. So proper affordances can be hard, but now you have also identified the user, so you have to think it not just in environmental terms, but also for the user you're targeting in that environment. If you're designing a new electric car, the user will of course be the car driver, but it will work in an environment of a society of smart cities and streets and all this. Then principle number 6. You should implement the green features that will lead to this overall sustainability of the green natural environment. And so this is where you bring your sustainability fit function into use. And it enables you to design and prioritize the green features. And here we have also worked a little further since we wrote the paper. So we have identified 3 ways of implementing the sustainability fit function. Automate, informate, and transformate. So automate is that you establish some eco-efficiency by designing natural resource efficient automation for behaviors and processes. So that's classic use of IT. Informate and automate, so you establish eco-effectiveness by designing information that capture relevant state vectors, big data or whatever, automate that can execute the state transformations, for example from unhealthy to healthy. And then the third thing is you can build in transformation, so where you transform and regulate the elasticity of the natural and social capital over time. So these are the 3 ways you can implement the sustainability fit function. So now we have problem analysis with 3 principles, design with 3 principles. So the 2 remaining principles is about evaluation and learning. So, but first a little update of our figure. So you derive the sustainability function, then you provide affordances for the sustainability, and then the key design green function, you automate, informate, and or transformate. So principle number 7 is that you should evaluate. and learn something. And there's something we know from prototyping and from a lot of you never get it right the first time. So you have to plan for a number of iterations, and you have to plan for your evaluations of these iterations. So iterate the appropriate design and evaluate whether it actually, and of course here you should evaluate the sustainability and whether you achieved what you wanted and actually implemented the sustainability fit that you planned for. And then you learn through a number of iterations of problem formulation, design, and evaluation, and slowly green IS will emerge. So that's the 8 principles that we have derived, and that leads to the conclusion. Our contribution is a design theory for green IS that builds on a careful definition of the relevant concepts of stakeholder, system, environment, sustainability. And we've described our theory in terms of 8 novel design principles. And we believe that this will allow a designer that wants to design green systems to actually truly label what is coming out as green IS.